In my last video, we looked at a basic introduction to integration. In this video, we're just going to work through a few examples, some of which will be easy and some of which will be more challenging. All we're initially doing is looking at finding indefinite integrals when we have powers of x. So let's just recap what we saw in the last video. If we have the integral, and here's the integral sign, of x to the power of n with respect to x, this gives us now x to the power of n plus 1 divided by n plus 1 plus a constant of integration. And we say that n cannot be equal to -1. This looks a long-winded expression, or I should say equation just here, but essentially all we're saying is raise by a power, divide by the new power, and add a constant of integration. So this will work for powers of x as long as n isn't -1, as that will be logarithmic integration, which we'll see in later videos. So let's go ahead and use this. So in question 2, we're asked to find the following indefinite integrals. These are indefinite integrals as we don't have limits on our integral sign. In a later unit, we will look at evaluating definite integrals, and generally speaking, that will be done to give us the area under a curve. So let's go ahead. What we can say now is that the integral of 2x plus 1 with respect to x. What we do then is raise by a power, so it becomes 2x to the power of 2, and divide by the new power. Then we have x now to the power of 1 divided by 1 plus a constant of integration. So we can go ahead and tidy that up and simply write it as x squared plus x plus c. That gives us now the integral. The integral is essentially the antiderivative. So we're looking at now at finding a function that gave us the derivative 2x plus 1. So if we look at this now, if we did differentiate it with respect to x, so the derivative with respect to x of x squared plus x plus c, well, that's going to give me now 2x plus 1 plus 0. And we can see now that the 0 comes in, and that gives us exactly what we wanted. So all we're doing is reversing this. So what we're going to have now is the integral of 3x to the power of 3 minus 2x, and we're integrating with respect to x. So we'll have 3x to the power of 4 divided by 4 minus 2x to the power of 2 divided by 2 plus a constant of integration. So we can write this as 3/4 x to the power of 4 minus 1 lot of x squared plus a constant. You have to be fairly comfortable now in terms of fractions, especially if we get any fractional powers. Raise by a power, divide by the new power, add a constant of integration. So let's now look at the next one. We've got this one just here. So we've got now the integral of 4x to the power of -3 minus 2x to the power of -5, and we're integrating with respect to x. So we get 4x to the power of -2, we're raising by a power, that's not going to go to 4, divided by the new power. Then we're going to subtract from that 2x to the power of -4, raising by a power, dividing by the new power, and adding a constant of integration. So tidying up, we're going to have -2x to the power of -2. We've got two negatives, so it's going to be plus 1/2 x to the -4 plus a constant of integration. Again, different forms that these can be written in. If you wish, you might want to write that as -2 over x squared. We're not asked to put it in any particular form, so I'm going to leave it like so. Okay, the next one here, question D, we've got to deal with this root x. We've seen in previous units that the root of x is x to the half. So we're looking now at the integral of -x to the power of -5 plus x to the power of 1/2, and we're integrating with respect to x. So we'll get now -x to the power of -4 divided by -4 plus x to the power of, we're going to add 1. Adding 1 will take me to 3/2, we need to divide by the new power of 3 over 2. Dividing by 3 over 2 is the same as multiplying by 2/3. Add in a constant of integration and tidying up. So we've got the two negatives, so I'm going to write this as 1/4 x to the power of -4 plus 2/3 x to the power of 3 over 2 plus our constant of integration. That is a simplified expression for the integral now of -x to the -5 plus root x with respect to x. Okay, let's look at the next one. So we've got now the integral of 7 minus x now to the -5, and we're going to integrate with respect to x. So this will give me now 7x to the power of 1 divided by 1. Depending on your teacher or the course, you might not have to do this. You might simply be able to just write 7x. Minus x to the power of 2 divided by 2. Remember, that's just a little 1. Then we're going to get, we're subtracting x to the -4 divided by -4 plus a constant of integration. So this is going to give me 7x minus 1/2 x squared plus 1 over 4 or 1/4 x to the -4 plus a constant of integration. Okay, let's look at this one right here. So what we've got here, we've got the integral of 4x minus c over 2 with respect to x. We're told c is just a constant. So when we integrate a constant, we get that constant multiplied by x. So for example, if I had now the derivative with respect to x of 3x, that would be equal to 3. If I have the derivative with respect to x of 10x, that's going to be equal to 10. If I have the derivative with respect to x of px, let's just put that there rather than put equals. If I have the derivative of px, that's going to be equal to p. So exactly the same. All we'll have to do is introduce a different value or a different letter for our constant of integration. So let's go ahead and integrate this. So what we've got then is the integral now of 4x minus, and if you want to put, you can put 1/2 c with respect to x. That is going to give us now 4x to the power of 2 divided by 2. So if you think that's going to give us 2x squared differentiates to 4x, therefore 4x integrates to 2x squared. Okay, this is now what we need is 1/2, and then let's just jot that down, cx. Now you can put 1 here and divide by 1. I'm not going to put that. C is just a constant. If you really want, like I did here, 7x to the power 1 divided by 1, you can do. Plus now d. D is my constant of integration. I've already used c, so I'm going to introduce d. So if we want to write this out, 2x squared minus 1/2 cx, so c could be 5, it could be 10, it could be 20, plus d, and again, d could be something entirely different. So don't be scared to introduce these, it's perfectly fine. Okay, let's move on and do the last one. So this one right here, we've got now the integral of ax cubed plus bx squared with respect to x. A and b are constants. So the variable we're integrating with respect to is x. It's not a, it's not b. So what we'll say then is the integral of ax cubed plus bx squared, and we're integrating now with respect to x. We will get ax to the power of 4 divided by 4 plus bx to the power of 3 divided by 3 plus our constant of integration. If we had had cx plus d, then we would have introduced, for example, e as the constant of integration. So you can leave that as it is. If you want to write it 1/4 ax to the 4th plus 1/3 bx squared plus c, you can do. Either form is perfectly fine. Again, these are identical expressions. So all we're doing is looking at integrating with respect now to a given variable. We're not asked to have y in terms of x because we're not told that dy by dx is equal to one of these particular expressions. So they are just now indefinite integrals and they're written as expressions. Okay, find an expression for f of x for each of the following. So what we've got here is f dashed of x. So what we can say then now is the following. We can say that the integral of f dashed of x with respect to x will give us now f of x. Again, indefinite integral because we will have, we've got no limits, so we'll have some expression that involves a c here. So remember, if we're differentiating, if we do the derivative, so the derivative with respect to x of f of x, this is going to give us f dashed of x. So all we're doing is now reversing this process. We are looking now for the function that gave us this derivative. So what I can say then is that the f of x will be equal to the integral now of 3x minus 4 with respect to x for question A. So we can write now f of x is going to be equal to 3x to the power of 2 divided by 2 minus 4x to the power of 1 divided by 1 plus a constant of integration. So we can write on here that the f of x is going to be 3 over 2 x squared minus 4x plus c. So that is an expression. We can find the value of c if we're given boundary conditions, i.e. a point that f of x would go through, but for now we will just leave it like so. Okay, the next one, so what we can write here, and I'll just write f of x will be equal to the integral of this right here. So I'm going to have x to the power of 4 divided by 4. We're going to subtract from that 4x to the power of negative 4 divided by negative 4. Remember, we're not just dividing by 4, we're dividing by negative 4 plus c. So that's going to give me, tidied up, 1/4 x to the 4th plus x to the negative 4th. We're going to have these cancelling, the negative 4 and the negative 4, and then we're going to have plus c, our constant of integration. Okay, let's look at the next one. We've got here, so this is still f dashed of x, the first derivative. We've got x to the half plus root 2 x to the negative 2. Now this root 2 is simply a constant in front of the variable x now. X to the negative 2. So what I'll say then is that the f of x will be equal now to the integral of x to the 1/2 plus root 2 x to the negative 2. And all we're doing is integrating this with respect to x. So I'm just simply going to raise by a power and divide by the new power and add c. Okay, so let's go ahead and do that. So what we'll do is have now x, and we need to raise by the power of 1. So that's going to give us x to the power of 3 over 2 divided by 3 over 2. Remember, dividing by 3 over 2 is just the same as multiplying by 2/3. Then we're going to have plus root 2. We will have x to the power of negative 1. We're raising by a power, dividing by negative 1 plus a constant of integration. So we can write this now as 2/3 x to the power of 3 over 2. Then we're going to have now from that subtracted root 2 x to the negative 1 plus c. Again, you could write this as now root 2 over x. Rules of indices, we've seen it before. Okay, this one right here, it's pretty hard to see the notation, but this is f double dashed of x. So what we'll do, we'll integrate now. If we integrate f double dashed of x with respect to x, this is going to give us now f dashed of x. So this is going to be quite interesting, as we're going to end up with having two constants of integration when we integrate. So let's integrate once. So what we can say then is f dashed of x is going to be equal to, and we need to be careful, we're going to have 1/2, and we're going to have x to the power, we raise by a power, adding 1 power is 4 over 3, and we're going to divide by 4 over 3. Then we're going to have plus 8x to the power of negative 4 divided by negative 4. So all I'm doing is raising by a power plus c. Okay, so let's go ahead and tidy this up. So we want an expression now for f dashed of x. So f dashed of x is going to give us now, what's that going to give us? 3 over 8. So let's go ahead and write that. 3 over 8 x to the power of 4 over 3. then this is going to give us now minus 2x to the power of negative 4 plus c. So what we need to do now is integrate this again. So the integral of this right here will give us f of x. So f of x we need to raise by a power. So we're going to have 3 over 8. X to the power, we need to increase this. So this is going to go from 4 over 3. Remember, we're adding 3 over 3. That's going to be 7 over 3. Divided now by 7 over 3. Then we're going to have, from that, subtracted 2x to the negative 3 divided by the negative 3 plus. Now this is going to go, remember this is just a constant. If we integrate a constant, we're going to get plus cx, and then we need a constant of integration, and that's going to be now plus d. So what's that going to give me? 9 over 56. Let's just write this out. So f of x. So f of x, hopefully my basic multiplication and division is holding true. So that's going to be 9 over 56. So 9 over 56 x to the 7 thirds plus 2 thirds x to the negative 3 plus cx plus, so plus cx plus d, and that there is going to give my final answer. If you wanted, you could do that just to show, again, depending on what your teacher, your exam board, or whoever you're doing this for requires. Let's just tidy that up to make it look a little nicer, and that should hold true. Hopefully, as I said, my fractions have held up. If not, hopefully you see the technique that we require. If we've got the second derivative, we need to integrate twice. That means we're going to have two constants of integration. We introduce c on the first one. That then becomes now cx, and introduce d on the next one. So if we integrate it again, which is perfectly fine, we would have now on this one cx squared over 2 plus dx plus e. Okay, let's move on and look at some more. So this one right here. Given we need to find an expression for y given the following. So we can say now that y will be equal to the integral of these. Remember, what we've done here is differentiated. So when we're doing integration, we're reversing the process of differentiation. We're trying to find the function that gave us the derivative 4x minus x squared. So what I can say then is y will be equal to, on the first one now, the integral of 4x minus x squared. And we're doing this with respect to x. So these ones are probably easier than the last ones, but again, we're just looking at different notation. So what we can say then is that y will be equal to, we raise by a power and divide by the new power. We're going to raise by a power and divide by the new power and add c. So y is going to be equal to 2x squared minus 1/3 x cubed plus c. Again, if you want to check that that holds true, differentiate this function right here, and you should now get the derivative dy by dx. So differentiating both sides of that equation with respect to x will give you that. So what we can say on the next one is y is equal to the integral now of 3 plus 4x minus 2x cubed, and we're integrating with respect to x. So we'll say that y is equal to 3x to the power of 1 divided by 1 plus 4x to the power of 2 divided by 2. Then we're going to subtract from this 2x now to the power. We need to increase this by 1 power, so that's going to be x to the 4th, and then we're going to go ahead and divide that by the 4. Plus c, so tidying up, we can say that y is going to be equal to 3x plus 2x squared minus 1/2 x to the power of 4, and then we're going to have plus c. So that's, don't be alarmed that there's no term in x cubed here. We've got x squared. We could see that. A constant's going to go to x, a term in x is going to go to x squared, a term in x cubed is going to go to a quartic of x to the 4th. Right, this one right here. Again, we've got this c. C is just a constant, don't be scared of it. So y will be equal to the integral now of dy dx with respect to x. So it'll be equal to the integral now of 9x plus c with respect to x. So we can say that y is equal to 9x squared divided by 2 plus cx to the power of 1 divided by 1, if you like, plus our constant of integration, and we will call that constant of integration d. So y is equal to 9 over 2 x squared plus cx plus d. Whatever you do, don't try and get into decimals here instead of fractions. We leave them as exact fractions. It makes now the workings out so much easier. Okay, let's look at, oh sorry, that one, is that one we've just done? Let's go, we need to do this one, don't we? There we go, that's where we are. Right, we've got the second derivative. So what we can say then is that dy dx will be equal now to the integral, I thought I'd nearly missed one then, 9 minus x dx. So that will give us dy dx. d2y is the second derivative, therefore integrating will give me the first derivative. What are we going to have on here? That's going to be, and I'll just write it out quickly, 9x minus 1 half x squared plus now our constant of integration. So hopefully by now you're fairly happy with what I've just done. If not, just stop it. 9x, 1 half x squared subtracted plus c. So what we can say then is that y is going to be equal to the integral now of this right here. So 9x minus 1 half x squared plus c integrating with respect to x. So if you took y, differentiating it twice, it would give you this expression. So integrating it twice will take us back. But of course, we will now have d as our constant of integration, and we could find that if we had the boundary conditions, i.e. it went through a point, let's say 2, 4. So y is going to be equal to now 9, and then we're going to have x squared divided by 2, minus now 1 half x cubed divided by 3. Now at this point I would simply write that that's 1/6 plus cx to the power 1 divided by 1 plus now d. So tidying this up, y is equal to 9 over 2 x squared minus 1 over 6 x cubed, and then we're going to have plus cx plus d. So you can see when you differentiate this twice, the first time you differentiate it, the d will disappear and just give us c. The second time you differentiate it, the c will disappear and just give us now this linear function 9 minus x. Okay, so back to now what we can say then is the following. We can say that y is going to be equal to the integral now of this right here. We've got ax plus b all squared, where a and b are constants. In this particular unit, we don't do this by inspection or reverse the chain rule. In later units, you'll come across reversing the chain rule or integration by inspection. For now, we've just got to expand this out. So if I expand this out, what we're going to get is a squared x squared plus 2abx plus b squared. So if you want to do that step by step, that's what we're going to be integrating. Now remember, we're integrating with respect to x, so that will give me a squared x cubed divided by 3 plus 2ab x squared divided by 2 plus b squared x plus c. We haven't used c, so c is our constant of integration. Remember, these are just constants. So we can write that y is going to be 1/3 a squared x cubed plus ab, with the 2's cancelling, x squared plus b squared x plus c. So a bit messy, but essentially all we're doing is integrating. So for example, if you wanted to put in a was equal to 2 and b was equal to 1 or something similar, you would see that that's a very straightforward integral once expanded out. But again, we've got these a's which become a squares as a result of squaring the bracket, but hopefully that makes logical sense. So that would be now the integral now given dy dx. So if you're asked to find an expression for y in terms of x, all you're doing is integrating the derivative. It is now the antiderivative, or we're finding a function that differentiates to give this particular expression. Okay, let's look at some others. We're asked to find now the following indefinite integrals in the form y is equal to the f of x. So what we would essentially have is that now if we were integrating these, this would be y. So we're introducing y as a function of x. So on the first one, again, we need to expand this out. So we can say that y is going to be equal to the integral now. And what's that going to give me? 2. Then we're going to have, 2, then we're going to have minus 2x plus 3x, which is going to be plus 1x. And then we're going to have minus 3x squared. So again, all we do is expand out, and that should be nice and straightforward. Hopefully that's what it should be. So we can say now that y is going to, and I'll just do this relatively quickly. In this one, in fact, I'll work it backwards, and hopefully you'll see over time an easier way to do it. So I always say to myself, what differentiates to give 2? And the answer is 2x. What differentiates to give x? Well, that's going to be 1/2 x squared. What differentiates to give 3x squared? Well, that's going to be x cubed. So you can see now, if you want to do it quicker, that's essentially it. What differentiates to give 3x squared? Well, it's x cubed. I'm not showing workings, but later on it would be okay for you to do that, hopefully. Okay, let's look at this one. So we got the integral now of x root x. Remember, this is x to the half. So we can say that y is going to be equal to the integral now. So x to the 1 multiplied by x to the half is going to give me x to the power of 1.5, or we could say 3/2. Then we can have minus 3x. So minus 3 lots of x, and we're integrating with respect to x. So we can say that y is going to be equal to x to the power of 5/2 divided by 5/2 minus 3x squared divided by 2 plus our constant of integration. So dividing by 5/2 is the same as multiplying by 2/5. So x to the 5/2 minus 3/2 x squared plus our constant of integration. If I'm making any slips on these, I do apologise. I'm kind of doing them off the top of my head. But hopefully you're getting the technique at least. Right, this one, we need to split this up. We've got now a numerator and a denominator. So as we did with differentiation, we split it up, and we can say that y is going to be equal to the integral. What we'll have is 3x over x to the half, which is going to give me now 3x to the power of 1/2. If we're dividing, we subtract the powers. Then what I'm going to have here is now negative 1 over x to the half, which is going to give me now minus x to the minus 1/2. So that is what we're looking for. All I've done is use the rules of indices. If you wanted to split it up, you could say 3x over x to the half minus now 1 over x to the power of 1/2. If you want to do that way, you can do. If you're comfortable to write it like this, go ahead and do it. So y is going to be equal to 3x to the power of 3/2 divided now by 3/2. Then we're going to have, subtracting from that x, we need to raise this by a power. So going up from negative 1/2, adding 1 will give us 1/2. Let's just scroll down a little and extend that. So that's going to be now 1/2 plus a constant of integration. So y is going to be equal to, if we divide 3 by 3.5, that's going to give us 2. So 2x to the power now of, what did we have, 3/2? Let's write that in. So 3/2, and then we're going to be left now with minus 2x to the 1/2, or if you like, 2 root x plus c. So again, hopefully my rules of indices have held up, and basic manipulation of fractions. But as you can see, we're half an hour in, so I'll sort of pretend that I'm tired if any of these go wrong. Okay, let's just rewrite this one. What we've got then is the integral of 2x to the power of 1/3. That is the cube root of x. Remember our rules of indices, cube root. And that's over x to the 1/4. So this is going to be messy. And this is going to be minus now 3 over x to the 1/4. Okay, so what we're going to have then is a third minus a quarter. What's that going to give me? A 12. So that's 4 twelfths minus 3 twelfths. Again, when we're subtracting, when we're dividing, we subtract the power. So that's going to be the integral now of 2x to the power of 1/12 minus 3x to the power of now negative 1/4. So this is a bit messy, and we're integrating this with respect to x. So what we're going to have then, we can say that y is going to be equal now to. So this is going to be 2x. We need to raise this. So this is going to be 13 over 12, adding 12, divided by 13 over 12. Then we're going to subtract on here 3x. We need to raise this by a power. Adding 1 from negative 1/4 will give me 3/4, divided by 3/4 plus a constant of integration. So as we can see, this is going to be a little messy. Y is going to be equal to 24/13, x to the 13/12. Then we're going to have minus 4x to the 3 over 4 power of 3/4 plus c. Okay, let's do this last one. Right, this looks a bit messy. What we've got here, let's rewrite it. We can say that y is the integral now of 1 minus 4. Now, this is the square root of x to the 5th. So we could write this as a power as x to the power of 5 over 2. And we're integrating with respect to x. So it's a square root of x to the 5th. So y is going to be equal to x, if you really want, you can write it as x to the 1 over 1, minus 4x to the power of 7 over 2, divided by 7 over 2, plus a constant of integration. So if we go ahead and tidy this up, y will be equal to x minus 8 over 7, x to the 7 over 2, plus c. So a bit messy. Rules of indices, split them up, simplify them, integrate them, add a constant. Okay, let's move on. We'll do one more. Question 6. Given that y is equal to x root x minus 3 for x greater than 0, find the integral of y with respect to x. All it's saying then is the following. We insert this just in here. So what we're looking for then is the following. We're looking for the integral now of x root x minus 3 with respect to x. So I've included this one as the notation is very slightly different, but all we're doing is putting this in. So x times by root x is going to give us now x to the power of 3 over 2, and then we're going to have minus 3x. So very, minus 3v, let's just take that off, minus 3. Very similar to a previous one, and all we need to do is integrate this. So let's go ahead and do that. We can say now that the integral, and you might want to write this, the integral I is going to be equal to, and sometimes we use I, don't have to, x to the 5 over 2 divided by 5 over 2 minus 3x to the power of 1 divided by 1 plus c. So that's going to give me now 2/5 x to the 5 over 2 minus 3x plus a constant of integration. So there we go. That's, well, over half an hour of just getting used to now integrating powers of x, simplifying, rewriting, integrating and adding c. So I think in the next video we will start to look at finding the constant of integration, but for now hopefully that's giving you an idea of how to find an indefinite integral in terms of a power of x.